We jump into 4.1. Technically, the chapter we just finished was trig, but this is, in my brain, our first real trig chapter. Okay. Chapter 4, we start to learn all about the unit circle. Okay. But before we get to the unit circle, we kind of we talk about degrees and then how that matches up with radians. Okay. Because in trig, we sometimes use degrees, but we very often use a measurement called radians. So let's start with some degrees, though. A degree, represented by the degree bubble, degree symbol, whatever you want to call, is a unit of angular measurement equal to 1/180th of a straight angle. Because what are there in a circle? In a circle, there are, 360 degrees in a circle, yes. What's a straight angle? A straight angle is a straight line, okay, like a straight line, and a straight line measures 180 degrees. So they're defining a degree to be 1/180th of a straight angle, okay? You could say it's 1/90th of a right angle. You could say it's 1/360th of a circle, okay? Now, before we jump into radians, we need to talk about DMS, degree, minute, second. Okay, we kind of introduced this. We don't do a lot with this one throughout the chapter, but it's still pertinent information. So in degree, minute, second, system of angular measurement, each degree is divided into 60 minutes, which is denoted by, I think of it as kind of like an apostrophe symbol. And then each minute then is divided into 60 seconds, which is divided by, it's a double apostrophe, or kind of like a quote mark, right? Okay. So this degree, minute, second, I think about it when we talk about, we've talked about latitude. If you really break down, latitude and longitude, and you talk about, like, I don't know the measurement, but tricentral is at a certain latitude, right? But we're not just at a certain latitude. They usually take a measurement of latitude and they break it down into, okay, we're at a certain measurement of latitude, so many minutes, so many seconds. Okay? And so that's what DMS works with here. And so we're going to do a little conversion and being able to go back and forth. So if we start with 37.425 degrees, so 37 and 425 thousandths degrees, being able to take that and break that into degrees, minutes, and seconds. Okay? So if we want to break this into degrees, minutes, and seconds, what do we already know? What are the degrees? Well, just think in terms of whole degrees. 37 degrees. So what we know right now is that this is going to be 37 degrees, so many minutes, so many seconds. Now, this 0.425 degrees. That 0.425 degrees represents the minutes and seconds. Okay? It represents the minutes and seconds. What did we just talk about? Up above it says each degree is what? Each degree is divided into 60 minutes. Okay? So when you talk about converting units, we've done this before in algebra, you've done this in chemistry, but each degree, so 1 degree is equal to 60 minutes. We can think of this, so if you think about this as 0.425 degrees over 1, think about multiplying as a fraction. 1 degree is 60 minutes. Do you know where I'm going? If I say we can either multiply by 1 degree over 60 minutes or 60 minutes over 1 degree. Which way do we want to make this happen? We're going to want the 1 degree, 60 minutes. What do we currently have on top? We currently have degrees on top. What do we want degrees to do? We want degrees to cancel out. Maybe we're not with me. Okay.
But I guess the ones are.
We want the labels to cancel out. Okay. So basically, I guess what I'm trying to ask is, I have 5 degrees. How do I change that to minutes? Based on the fact that 1 degree represents 60 minutes. So my recommendation, I mean, ultimately, what are we going to end up doing here? It's multiplying, isn't it? Okay. This is just kind of the why behind it. But the idea that degree label can cancel with degree label, and when we multiply this, whatever 0.425 times 60 is going to be our minutes. Mathematically, what do we get there?
25.5.
And so officially that is 25.5 minutes, yes? Because we just converted degrees to minutes. Now, we're supposed to be going to degrees, minutes, seconds. We already got degrees. What do we know about minutes right now?
26.
No.
25.
We have 25, yes?
Never round.
We're not rounding right now.
Never.
So what I know in my answer, we had 37 full degrees. How many full minutes do we have?
25.
We have 25 full minutes. And then do you see where I'm going with this? What do we have left over? We have 0.5 minutes left over, which this one's an easy one, isn't it? 0.5 minutes is 30 seconds. Mathematically, if I want to show this, it's taking this right here. I can do this the same way I just did the last one. 0.5 minutes. What do we know about minutes and seconds? 1 minute is 60 seconds. And so you can set this up the same way we did last time, where if minutes is on top, I'm going to put 1 minute on bottom and 60 seconds on top. And again, your labels can cancel. And I'm going ahead and doing this because are they all going to be this nice, neat, oh, you have half a minute left over and you know half a minute is 30 seconds? No. But now the idea is the minutes can cancel. We already know 0.5 times 60 is 30. That's going to be 30 seconds. And that's the final piece of your answer. So 37 degrees, 25 minutes, and 30 seconds. Now, how much did I confuse? Did I get us there eventually? Okay. Are there other ways you can think through this? I would say yes. Okay. Do you have to set it up as fractions like this? Not necessarily. Okay. But if you're looking for the math behind it, you know, the solid math advice, this is what I'm going to say. Okay. Think about it in terms of conversions. Okay. Ready to try B? Okay. So, we're being asked to convert 157 and 892 thousandths degrees to DMS, degrees, minutes, seconds. So what do we know about degrees? How many whole degrees do we have? Okay. We know, without doing any work, we are at 157 degrees. What does that mean I have left over at this point? 0.892 degrees. What am I going to convert degrees to?
Minutes.
We need this partial degree to convert to minutes. What's the connection?
60 minutes over 1 degree.
Yeah. 1 degree is equal to 60 minutes. We put 60 minutes over 1 degree because if degrees is on top, we want degrees to cancel. And I wasn't lying when I said you wanted the calculators today, right? So 0.892 times 60 is 53.52. And what is my label at this point? Minutes. Okay, so what do we know goes towards our answers? How many whole minutes do I have? I have 53 whole minutes. It's going to go over towards my answer. What do I have in terms of leftover minutes? 0.52 minutes. And here is where I gave you a method because do you know what 0.52 minutes in terms of seconds? It's not as obvious as the last one, is it? So 0.52 minutes What do we know about the relationship between minutes and seconds?
60 seconds ago.
There's 60 seconds in 1 minute. Put 60 over 1 because we want the minutes label to cancel out. So we cancel the minutes label out. We're now at seconds. 0.52 times 60. 31.2, and that would be, well, it's seconds is where I was going with that. Now, here's the deal. Do we have any more conversions to do? No. So at this point, I would take that whole 31.2 and put it in your answer. Okay? The other ones, I have more conversions to do. So I'm taking the decimal pieces and I'm changing them. I'm converting them. This one, I'm done. And so I'm going to take the entire 31.2 seconds. Okay? Okay. Ready to go the other way? We need to convert. We're being asked to convert 42 degrees in 24 minutes and 36 seconds, 2 degrees. So I just want 1 degree answer. Which, without doing any math, what do you know about your answer?
42.
Okay, are you with her?
Yes.
Without doing any work, I know my answer is 42 point something degrees. Do we know the something? We don't know the something. Okay? And so that's where we're going to have to take 24 minutes and the 36 seconds. Okay? 24 minutes.
Yep.
What are we going to have to do to convert 24 minutes?
Divide it by 60.
Divide it by 60 because what were we doing to go the other way?
Multiply.
We are multiplying by 60. So now to reverse it, we can divide by 60. Okay. Now, and let's see. Looking to see how I wrote this in my notes. I wrote this a little bit differently in my notes. And let's see. Okay. So we're going to have, and I have a way that you can put this all in the calculator at once is what it comes down to. But, so we know we're going to have the 42, right? Then, you just told me we're going to take the 24 minutes and do what with it? Divide by 60. What is that 24 minutes divided by 60? Was it 0.4?
Yeah.
Okay. So what do I have for my answer right now? So far, if we stopped right here, we'd be at 42.4. What else do we have to do?
36.
It's 36 seconds. We're trying to get it to degrees.
You have to divide. You have to divide by 0.
Thank you. Caitlin!
We talked all about. Very glad to see you. We were very nervous.
I don't like what that says.
Yeah, I'm totally bored.
Ooh.
Yeah, many bands, no more guys. And you're here? Yeah.
We were hoping it was just an appointment.
I was going around the curve and I started to slow down like before it because I knew it was slippery but the whole road was just ice, so I couldn't slow down at all. And then I was going around and I just slid off the road and smashed the toe. Brian did the exact same thing last year. The exact same.
Well, you're here though.
Yeah,
That's what matters.
So good.
Okay.
She needs it.
Huh? Oh, she does need notes, doesn't she? I'm sorry, I'm just trying to continue.
Maybe she doesn't.
Well, I don't know. Need debatable story here, but want is the debatable story, right? Okay. So we're trying to figure out. Okay, guys, it was 36 seconds. We're trying to get back to degrees. If we take 36 seconds and we divide by 60 once, what's that going to take us to? That's going to take us to minutes. So then you get that answer, and you're going to have to divide by 60 a second time to get back to degrees. So what? Not 120. I'm going to write it.
360?
3,600 technically. Okay.
Oh, you're right.
Okay, so the idea here is I just wrote it as 60 squared. What's the alternative to writing 60 squared if you prefer? Yeah. You could also say, okay, 60 squared, I'm going to divide by 3,600. Okay, that's dividing by 60 twice is what it's doing. Okay?
Why?
Okay.
Why are we dividing it by 20?
Because if you take seconds and divide once by 60, it's going to take us back to minutes.
Okay.
And so we need to get to, we're trying to ultimately just get to degrees. Okay? Okay, so 36 seconds divided by the 60 squared, or by 3,600, is going to give you what? 0.01. So we have the 42 degrees. Then we got the 0.4 degrees. And now we have the 0.01 degree. What is all of this put together? 42.41 degrees. Now, I don't know if you guys caught what I wrote up here. You can enter this in the calculator all in one big fell swoop if you want. Okay? As in, do you see where I'm going with this? You could do 42 plus the 24 divided by 60 plus the 36 divided by 60 squared, or 3,600. So it's something to play around with, to practice with. Okay? In this one, it was pretty easy to add the pieces together. You'll see in the next one, it's not quite so easy to add the pieces back together. I mean, you have the calculator there. Okay? So, let's look at D. We're being asked to convert 125 degrees, 56 minutes, and 35 seconds to degrees. So, if you had to write anything, what do you know about your answer?
55.17 degrees.
Okay, we're going to be at 125 point. It's a matter of what about that 56 minutes and 35 seconds. So if you want to put it all in your calculator at once, you can, or you can do it in pieces. What do we do with 56 minutes? You're going to divide by 60, and that will turn into degrees. What is 56 divided by 60? 0.93 with their 3 repeat. And this is where the calculator comes in handy, doesn't it? Because adding these pieces, so right now I'm at 125.93 repeat. But we need the 35 seconds. What are you doing with the 35 seconds? You're dividing by 3,600 or 60 squared. And when we do that, you get something fun, don't you? 0.0097 to repeat. And this is where I say adding this by hand is not fun, is it? Okay. Option 1. Could you just enter this as one big thing on your calculator? Definitely. Option 2. If you have individual pieces, you know how to go up and copy something on your calculator, right? Do 125 plus, get the result of this one, plus, get the result of this one, and add them that way. Okay, guys, what do we have?
125.9430556. How far did we get? Right?
I don't know. I honestly don't remember what homework says. I have it all written out in my notes. I'm not saying you'd have to have it all written out to get it correct by any means. Okay? But that gives you an idea. Okay. The next section of this is converting degrees and radians. Okay? So we will be using radian measures a lot. Okay? We'll learn on the calculator how to go back and forth between degrees and radians. You'll get to be very familiar with that mode button on your calculator. Okay? But when working with trig functions, okay, we'll be using radian measure. Each degree has pi 1/80th of radians. Okay? What we're going to learn, we talked about a straight line being what? That is 180 degrees, yes? That is also a measurement of pi. Okay? In terms of radians, that is pi radians. So, in order to convert something, so it says up there each degree has pi over 180 radians. In order to convert from degrees to radians, or radians to degrees, you're multiplying by a fraction. Either pi over 180 degrees or 180 degrees over pi. So if you're wanting to get from degrees to radians, we're going to multiply by pi over 180 because we're trying to get the degrees to cancel. If we're going to go the other way, to convert from radians to degrees, we're going to multiply by 180 over pi. Okay? And so the first one we can do real quick. How many radians are in 90 degrees? Okay, we're trying to take 90 degrees and change it to what? Radians. How do we go from degrees to radians? You multiply by pi over 180. I'm not looking for a flat out decimal answer. Here's what I would think. Multiply this as is. If I say 90 pi over 180, what do you know about 90 over 180? It's 1/2, yes? This is most commonly written as pi over 2. Okay, and that would be pi over 2 radians. Now, connection. What did I just convert? I just converted 90 degrees. And I know you don't even know where 0 is, but what do you see sticking straight up on the unit circle over there? Pi over 2, which is 90 degrees, and that should make sense to you. Okay? So, we'll talk more tomorrow, we'll practice more tomorrow. We didn't get as far as we should have, but 2-hour delays kind of affect that. So, homework is there. You could look at the DMS section if you had the burning desire to get started. Other than that, we'll practice more tomorrow.